legitimacy to its existence. Time is the only true unit of measure. It gives proof to the existence of matter. Without time, we don't exist.
What's up, hackers? Welcome to Chill Code. My name is Taggart. I know my hair's a mess. I've been wearing a hoodie all day. There's nothing I can do about it. But other than commenting on personal hygiene, we're going to talk about Rust tonight. If you are interested in getting started with this programming language, which I used to despise and have come to love, then you are in the right place. We've done a couple of other intro videos on Rust, how to get started with it, how to make the most of it. But I think it's important to kind of cycle back to it every once in a while because people are interested in getting started, and information may update. The way that the language presents itself to new learners can change. So that's what we're going to do tonight. We're going to go through how to get started with Rust in the way that I figured out that sort of makes sense for at least my workflow, and I think is going to be the easiest way for most folks to get started. So let's get some prereqs out of the way first. You should have a computer. If you're watching this on your phone and you want to program Rust on your phone, you're going to have a bad time. Something with an actual processor, an x86 processor ideally, would be good. So something made by Intel or AMD would be rad. And you're probably going to want to have something that runs a flavor of a Unix-like operating system. That's a hot take right off the bat, but I find getting Rust going in Windows, most programming languages really, but certainly Rust, I find getting it going in Windows a major hassle. So, you have a lot of options. if you have a Linux virtual machine, which is exactly what we're looking at right here, I am on Windows. I'm coming to you live from a Windows machine, but this is a virtual machine in Hyper-V that I use for a lot of my programming and development. So it's KDE Neon, and it works great for me. If you're not interested in all of that, you can absolutely use Windows Subsystem for Linux to do this. Works great, especially if you keep everything that you do in Rust in the Windows Subsystem for Linux file system. So if you have that set up, you're also in great shape. You're gonna need a text editor. If you are super elite and can use Emacs, go for it. If you want to use Vim, I respect that. I use Vim all the time. Have at it. There are a lot of good plugins for Rust in Vim. Lowest common denominator, and frankly, the text editor that I use the most often with Rust is Visual Studio Code for a couple of reasons. One, it's just easy. Two, it has, I think, the best coverage and best user interface for some of the not IntelliSense, but the documentation hints, and also deep integration with the Rust analyzer, which we'll get to in just a minute. So basically the syntax checker and the error checker work really, really well in Visual Studio Code. So what you're looking at here is kind of my development environment whenever I'm working in Rust. I'm going to have the text editor up on the left. I'm going to have a terminal open in the right. I know that Visual Studio Code has a terminal built in, but I like my terminal better because it has Tmux and all that cool stuff in it. So this is usually how I set my stuff up. Those are kind of the prerequisites from a technical, from an equipment perspective, a materials perspective. Now let's talk about knowledge prerequisites. Can you learn Rust as a first programming language? Yeah, probably. I really don't recommend it. It is complex enough, and it introduces complex enough ideas, especially about computing and the way that computers work, that I would not recommend it as a first programming language, because as a first programming language, you have a lot of learning to do about the structure of code. How do you give instructions to a computer just at the base level? Understanding instructions in sequence, understanding variable assignment, conditionals, loops, functions, right? You have all of that to learn without the overhead of all the complexity that Rust introduces to you. So for the same reasons that I don't recommend Java or C or C++ as a first programming language, I don't recommend Rust as a first programming language. So if you're coming to this without prior programming knowledge, I strongly recommend checking out Python. Maybe you can check out some of the Python courses that we have at the Taggart Institute, like Python for Defenders, which is free, and Python for Defenders 2, which is not, but it is super affordable. Or you don't have to do Python as a first language, right? You can do other languages. I will say that before I started doing a lot of Rust, yes, I had done Python, but most of my day-to-day programming was in JavaScript. And it is possible to go from web developer down to a systems programmer with Rust. It is possible to do that. I did that myself. So as long as you have some prior programming knowledge, I think you'll be in good shape, just so that you're not bumping on the basics of giving instructions to computers. Okay. Those are the basics. Now, how do you get started with Rust? How do you install Rust? The great news is that in 2022, this has been true for a while, but in 2022, there's really only one place that you need to go, which is rustup.rs. If you go to rustup.rs, you are going to be given a script, and it is OS sensitive. So if you're on Windows, it'll give you a different script for that. But if you're on Mac OS or Linux, it'll give you a curl command. And what you're doing is you are getting a script, right? sh.rustup.rs, and you can go visit this if you want. You can go see the code. You don't have to take their word for it. And what this is going to do is kick off the install process in your terminal. So you take that script and you're piping it to your shell. So that's the basics of what's happening there. At which point you will be run through a basic install. When that is done, I've already done that just for expedience. But once that is done, you will have a couple of things available to you. Rust Up will be now part of your path. And the other thing you want to guarantee that is part of your path is something called cargo. Now, we're going to talk about cargo in more depth. What is happening here? We're going to talk about cargo in more depth later. But if we look at which cargo, you'll see that it is in my home folder in the .cargo directory, right? And there's this bin. So if I look at my path, you will see that part of my path is that home folder and then .cargo/bin, because there's some stuff in there that Rust needs to use, and cargo in particular. So you just want to make sure that that's part of your path. You can set that as part of your bash RC, or in my case, my config.fish if you're using fish. So you want to make sure that cargo is part of your path. That'll be available to you, or that'll be necessary eventually. You've got Visual Studio Code, hopefully, open. You can install that however you like. Code.visualstudio.com. I installed it via Snap on here so that it is always updated. And that's kind of where we're going to get started. So just to give you some basic shapes and basic ideas, basic concepts, we're going to write a stone stupid hello world, the classic program in a first language. I'm a traditionalist, so that's what we're going to do. We are going to touch hw.rs in a folder. I just have an intro to Rust folder, and we're just going to make a .rs file. You can see that little Rust icon there. Visual Studio Code knows that we're supposed to make Rust in it. Now, if you have the Rust extensions installed, and let's talk about those. What's up, Husky? If we search for Rust in Visual Studio Code, we'll see that Rust Analyzer is what we kind of want to have installed. And it is already installed, right? So we're good. But this is what you want installed. Despite there's this Rust 1.7 million, but notice that it is deprecated. Do not use this one. The tool you want to use with Visual Studio Code is Rust Analyzer, okay? It's 1.2 million. It's not the 1.7, but this is the one. Okay, and this is the language engine that will analyze Rust syntax for issues as you go. Now, Rust Analyzer freaked out at us right away because we're not running in a proper cargo project. But that's actually what I want to do. I want to show you that you can compile code in Rust files very similarly to the way that you would compile code in like a C file. There's a very similar pipeline if you want to do it bare bones, okay? That is possible. So we're going to just write in our Rust file here, we're going to write fn main, just like that, okay? Let me zoom that in so that you can see it. Hopefully that text is large enough. Let me know if it's not. I know that sometimes the VS Code text is a little bit tough to read. Maybe one more zoom. There we go. Okay, so fn main, we're going to close that browser, and we're going to use println, which is a macro, which we'll talk about soon. We'll say hello world, the basics, absolute basics, okay? We're going to save that out. So we've already learned something about the language. First of all, functions are declared with the fn keyword. We haven't done any arguments or return types, okay, because this function doesn't do any of those things. But we use curly braces to delineate. We use semicolons to end our statements, end our lines. And that's kind of it. And for compiled programs, we kick things off with a main function the way that you would in C or C++. Or Go, actually. All right, so we need to compile this thing. We need to get this running. How do we do that? Well, if this were a C program, we would use a compiler like GCC or CLang, right? Guess what? One of the things that you just installed, if you just installed Rust, was Rust C, which is the Rust compiler. So in your path, you should see Rust C, okay? And you can even run -h to make sure that you're getting some help details, right? If you want to see, I think there's a -V for version. Maybe not. -V for version. Okay. And it turns out that Rust C works very similarly to the way that GCC does. So if we run Rust C -o HW and then hw.rs, we're compiling. Now if we do another ls, hey look, an executable showed up. And if we run it, there's our hello world. You've just written your first Rust program. So far, not too tricky, right? We write the code, we compile it, we run it. Easy peasy. Generally speaking, we do not use Rust C. Rust developers do not use Rust C raw. And that is because while you totally can do that and your programs compile just fine, you miss out on all of the really cool helper features that the tooling around the language has available for you. And all of that resides within Cargo. But before we get too far ahead of ourselves with Cargo, already I can tell you that you're going to need to have documentation open in order to get the most out of the language and to reference things. And in fact, I would say maybe the most important skill, honestly, in Rust and maybe every programming language is understanding how to read the documentation well. But no language that I know of requires this more than Rust. There is a lot of documentation, and it is excellent. But if you don't understand how to read it, it will be overwhelming. And even though you will have access to all of it, you won't really know what to do with it. So let's get you started. The first bit of documentation that you're going to want is the book. The Rust programming book. And by the way, this is the same text, it's the same information as the No Starch Press book that you can buy for money. It's the same content, but this is just the online ebook version of it. This book will get you started on all of the stuff that you need to know to begin writing Rust. It does a great job of introducing the language, probably better than I will, but I'm going to do my best. Yeah, that's right, Sir Juicy Lemon. I mean, buy the book. I actually like books, so I bought the book anyway. And the kind of the next level book, Rust for Rustaceans, isn't anywhere else, and that book is. That book is amazing, but that's like next level Rust stuff. Okay, so you want the Rust book up, but the Rust book, like many technical documents, may assume understanding of terminology that you are missing. And if you're anything like me, sometimes an abstract explanation of something isn't sufficient. I need to see it in context. I need to see how it works, right? And for that, we have Rust by example. The Rust by example takes a lot of the concepts that are introduced in the Rust book and gives you direct examples of how they are employed. So these two are your starting points, the Rust book and Rust by example. This is, have these up, live them, love them, and then finally, one more. Which is the standard library. And this is the one that will begin to overwhelm you. Okay. Ah, that's much better. Okay. The Rust standard library. If you do not know how to read this, this one will be like drinking from the fire hose. As an example, let's take a look at the documentation for an 8-bit integer. If I can type I8 is what I'm trying to say. Yeah, there we go. So let's look at the 8-bit integer. Okay. And we want the I8 primitive type, actually. Okay. Lots of documentation, but without any context, does it make any sense? It does not. And so, hopefully after tonight, some of what we go over in the language will help this make sense. Every type is defined, that the standard library contains is defined well. And all of the things that the types can do are defined well. And those concepts are core to understanding Rust. If you're not used to a strongly typed or statically typed programming language, this is going to be an adjustment. Not impossible, but it's an adjustment because you've been thinking about not unstructured data, but you've been thinking about data in terms of instructions. How you write a function to do a thing to get a result. But in Rust or any strongly typed language, very much you are thinking about transformations of data types. What data shape do I start with? And how do I get the data shape that I need? And that is a fundamental shift in your thinking and one that will make you a better programmer. I promise. And solve a lot of errors for you. Is the Rust standard library something similar to the C++ standard library? Yeah, it's like the core of the language. Okay? It's the stuff that you get out of the box without installing third-party modules or libraries. Okay. Now, one of the things that you will see in the Rust book, we don't even get out of chapter 1 before we start talking about it, is this thing called Cargo. And Cargo is, as it says, Rust's build system. But I don't think that's a very useful term if you don't know what a build system is or if you never worked with one. So, do we have any web developers in the house tonight? What about Java developers? For web developers, Cargo is like NPM or NPX, right? It is the tooling that surrounds your project, manages dependencies, will run tests, will run dev servers, all of that stuff. That is what Cargo does for you. It will even publish your eventual package to I don't know why my VM is really on the struggle bus tonight. Crates.io, which is where people, Rustaceans, publish their open source Rust code for you to download. So Crates.io is the repository. If you look for anything, in fact, I should have a crate in here. There it is. So if you look at the crate, it will tell you how to install it, which we'll talk about in the Cargo file, but there will almost always be a link to also the source. So if you want to review the source directly, you can absolutely do that. All right. So Crates.io is another great resource to know about. And also, it's a good thing to get into the habit of, like, wondering, oh, does this crate exist? Go check it out on Crates.io first. Odds are somebody's already solved the problem that you have for you. Okay. So, with all of that being said, let's make our first Cargo project then. To do that, we're going to do Cargo new. Oh, hey, Day Zero. Yeah, no problem. Sorry that, sorry it was a bit of a swing and a miss. No worries. So, let's do Cargo new, and let's just do, okay, now's a good time to call our shot here. We're going to make a rock, paper, scissors game. I know it's a little bit contrived, but I've been teaching computer science for a long dang time. And rock, paper, scissors, the structure of it is just so good for teaching the fundamentals of a language. So we're going to make a rock, paper, scissors game. So we're going to do Cargo new RPS. Okay? What that does is it creates a binary application RPS package. And if we do an ls, now we'll see that we have an RPS folder. We're going to cd into that. And you can see that already, well, if you know anything about Fish and Bob the Fish, you can see that it's Gitified. It made a Git repository for us already. So if we run git status, right, you can see that we have stuff already ready to, it's waiting for us to become a working repository. But in addition, let's modify where Visual Studio Code is pointed. Let's point it to the RPS folder. Perfect. So we have a source folder, but we also have this cargo.toml. This is for the web developers. This is your package.json. Python developers, this is requirements.txt. I don't know how Java does it, something with Gradle. This is your dependency list. But it's more than that. It's also the metadata about your project, very similar, again, to package.json. So a lot of the data that you just saw in crates.io about my crate was pulled, actually all of it was pulled from here, right? And we can build this out with more detail. In fact, it will even tell you how if you visit the manifest reference at doc.rustlang.org/cargo. But we don't have any third-party dependencies right now. So we're gonna just leave that as is. I will say that Cargo doesn't have, like, if we run Cargo help, you have a Cargo add, but I almost never use it. I almost always add it directly by editing the cargo.toml file because it's just easier, right? Because I'm going to the crates.io to get the version of the thing anyway, and I already copied that over, so I just paste it in to cargo.toml directly. There's no reason for me to mess with that, but you can. There are a few other details about how Cargo works that we'll get to in just a moment, and the reasons why we like it. But for now, we also have a source folder. Inside of this source folder, helpfully, is a main.rs. Now, by the way, I don't know if you noticed, but when we ran Cargo new, it told us that it had built a binary, an application, which is the default. However, you can also configure Cargo to build a crate for a library, something that doesn't have a binary target necessarily, but is designed to be used in other projects. And in that case, you don't get a main.rs, you get a lib.rs. So just be aware of that subtle difference. And by the way, you can actually make a project be both a binary and a library if you want to do that. That is not impossible. Okay, but for now, we still have this function main, and if it looks very similar to the thing that we just wrote, it's identical, as a matter of fact. So if we want to run this thing, we can click on this run here, and so this is Rust Analyzer doing its job. It finally knows what to do because it's inside of a Cargo project. But if we want to run it manually, as I usually do, I do cargo run. And what will happen is if it needs to recompile the project based on changes that you've made, it will do so. It will recompile any dependencies, which is usually what takes the most time, and then it will run your code, just like so. And just to demonstrate that it works, going to use the very, very annoying, hard to use KDE emoji picker. All right, and then rerun cargo run. Didn't take that much longer to compile and run, right? Not at all, as a matter of, well, measurable time, right? 0.38 seconds to 0.97 seconds. But it didn't take that long to do, and the reason is that Cargo builds in stages. So all of the things that, when you have dependencies and they haven't changed, Cargo will just use the pre-built targets for them. You won't have to recompile everything every time you rebuild a project. So that's handy. If we run this again, you'll see it took no time whatsoever, because we made a small change that took a little bit of time, and then this one took no time at all. Oh, Barry, hey. Rust Nation UK is the first UK conference dedicated to the Rust language. It will be held at the Brewery in the heart of London on the 16th and 17th of February 2023. I wish I could join you. Whoa, actually, that's really funny. Because you know what is the day, like the day prior, Barry? AppSec Global is happening in Dublin on the 14th and 15th. So if you wanted to have just a great time across the pond, you could party it up in Dublin with the AppSec folks, the OWASP folks, and then go to Rust Nation. Boy, that would be a good use of a February. Okay. Let's make ourselves a rock, paper, scissors game. Let's think about the parts that we need to make a rock, paper, scissors game. I'm going to use comments to sort of call my shot in the way that I normally do. So the first thing is we will, for a 1 round, we will ask the player for a choice, rock, paper, or scissors, right? Okay, and then after that, we will generate a random computer choice. And then determine the winner. Those are the basics of the rock, paper, scissors game, right? And then if we want to be a little bit more specific with it, we can say confirm a valid choice, right? And then if invalid, re-ask. Okay? Those are the basics of a rock, paper, scissors game flow. So I'm going to ask chat, what are some ways, what are the first things we have to do in order to build this game in terms of code? What are the first things that we need to define? Come on, chat. I know you're out there. We don't have to be alone here in the cyberspace. We have to define the rules of the game. We have to define the choices and how do we determine who won, right? Rock beats scissors, paper beats rock for reasons surpassing understanding. Those are the things that we have to encode, express as ideas with our programming language. So the question then becomes, what tools does Rust have to make this easy? The first one is we're going to talk a little bit about the Rust type system. Okay. Actually, yeah, we're going to talk about the Rust type system and how we define things of specific types. We're going to do that before we get to defining the rules of the game. We're going to modify our main here to show you type syntax. We're going to say let message equal, and then we'll create, at the moment, the string. And the print line message. Now, Rust Analyzer has added this additional hint. Everything after the colon that you see in the kind of gray highlighting there, I did not write. Rust Analyzer did that for me. It's also yelling at me that I didn't put a semicolon at the end of the line. I did not write that. It did. But if I wanted to be explicit, I would put a colon and then the type of the data, the type of the variable after it. before the equal sign, but after the variable name. So let is our variable declaration keyword. Okay? We just learned a lot about the language here. To create variables, we use the let keyword, the name, and then, if we have to, a colon and then the type. Now, this and stir already is weird, right? What is this all about? These are called string slices, or I usually refer to them as string primitives. They are basic representations of strings. They are not the more complex capital S string that Rust also has, or lil strings. Yeah, they're so cute. But what's important about that ampersand, as we'll see later, is that they are always references, or pointers if you're a C or C++ programmer. Which means they kind of stay in one place. Okay? They don't move around. Which makes them very flexible in certain ways, but sometimes they can be a bit of a pain because you need things to move around. You don't want the reference, you want the thing. Hey, the Tattooed Technologist, thank you so much for the Prime sub. If I wanted to turn this into a proper string, and there are reasons why I might want to do that, because strings have certain powers, I have a couple of options. I can do a .toString, because that is a built-in method that string primitives have, and it is yelling at me now immediately because it's saying, hey, you told me this was a string primitive, but you gave me a capital S string. Fix it. If I just remove the type definition, that error goes away. Or if I fix the type definition such that it matches what it's supposed to be, which is a capital S string. If you want to know the difference, go to the documentation. There's your capital S string. This is the big one. And I do, in fact, want it to be a big capital S string for now, because I want to show you something kind of weird that Rust does differently than every other language. Okay, so we're making a string. The other way we could have done it, other than toString, is we could have started from string and used the built-in from method to produce a string directly from a string reference or a string primitive. Either way, we get a string at the end of the day. Now, println is now going to yell at us because I need to give it a formatted string. So that's fine. What I will do is I will cover this in quotes and wrap MSG in curlies, which will allow it to send the string into a format string, producing the thing that I want to print out. If we do cargo run, it recompiles, and it still runs. It doesn't seem like anything changed, right? Okay. So this is how we do type definitions at a base level in Rust. We have a colon, we have the type name, okay? Also notice that this double colon is how we access methods inside of structs and other structures that contain functions in Rust. If we look at the documentation for string, one of the many, it has from, a bunch of different kinds of from. Okay? And you might notice it doesn't have a direct from method. And that is because it implements it from another place. This place called from. We're not ready to talk about traits yet, but just know that the structs that we use, like strings or iterators or vects, as we get to those things, aren't just what are defined on them, but all of the other attributes that they implement that are also defined elsewhere. So they can contain more than is just explicitly defined in them. And from is one of those things. So strings, in addition to having all of those direct methods that we saw up there, has an implementation for from for string primitives. And therefore, we can use that from method on strings. I know that's a lot. Please do not hesitate to ask questions as we go. Now, I want to show you something a little weird. We're going to make a new function called greet. And greet this time is going to take a message, which is a string. Notice how we do argument definitions. So we do the name of the argument, :type. And if we wanted to, we would do a return type with a single dash arrow. In this case, our greet function isn't going to return anything, so we're going to leave that as is. We will write functions that return stuff in a second, but this one's just going to have side effects. And the reason is I'm going to move the print line over here. Okay? And then we're going to call greet of our message. Okay? I'm adding unnecessary complexity at the moment. Again, I'm sorry about that green artifacting. I'm not sure what's up there. Everything runs. Doesn't seem like we did anything different. Now watch this. This is the first gotcha that new Rust programmers run into. Almost every time. Seems sane, right? And Rust Analyzer's kind of giving away the game for us already. It's like, hey, you can't do that. But we're going to do it anyway. Something went very wrong. And here's why. It's hard to parse out what this is saying, but let's look at it anyway. It says use of moved value MSG. Delicious. Move occurs because message has type string, which does not implement the copy trait. If you don't know like any term in that sentence, that error message isn't helpful, right? You don't really know what that means. But it does tell you that the value was moved above on line 19. And then on line 20, it's saying you can't do this because the value was moved. Well, what does move mean? Okay. You've been struck by the smooth borrow checker. In Rust, one of the value adds, one of the value propositions of Rust is that it is memory safe. What does that mean? It means that the compiler is doing a lot of checking to make sure that you do not introduce overflows or use after freeze or anything else that is just about bad memory management. Rust does not have a garbage collector. It has like an upfront garbage collector at compile time because the compiler is making damn sure that code does not live and data does not live longer than it needs to. And it enforces that in a couple of different ways. One of these ways is borrowing. Meaning, if I send data from one context to another, or one scope to another is really the word that they use, you can do that once. But the second that you move it, it is that other function's problem, and as soon as that function's scope is over, so is that data. And there's nothing you can do about it. That is the core concept in the borrow checker. It's one of the more frustrating things that new Rust programmers run into because you don't know how to fix the problem. How do you get around that? Like, ChatGPT explains the error decently. Well, how did I do? compared to the symbol parsing robot. Oh, good. Not obsolete yet. So how do we solve this? There are good ways to solve it and bad ways to solve it. It's just a beta, though. Yeah. The easy way to solve it in this particular case is to not use a string for greet. It doesn't have to be a string. There's no need for it to be a string. So instead, remember that I said that the string primitives were always references, right? References don't move. So if we turn greet into a string primitive, and then if we want this to be a string for whatever reason, like we can do that, that's fine. But if we send a reference to the string now both times, now code runs fine. Because we didn't move anything. What we sent was not data, or data qua data. It was a reference to the data. So message never left scope. But we sent references about it. We sent out references, right? Hopefully we get a callback. Hey, Foxney, thank you so much for the follow. Or FoxNY, maybe? Okay, so I wanted to call that out as one of the first errors that you run into. Ah, yeah, Mastodon gang. Good to see the Fediverse represented. That's one of the first errors that you run into as a new Rust programmer. And you have to start thinking about how you move data and where data ends up. The borrow checker, luckily, has had a huge improvement in its error messages. It really is a lot more helpful than it used to be. But I also want to prepare you that if you are new to Rust, part of the process is that you are going to have to make a lot of mistakes and run up against the compiler and the borrow checker a lot. That is part of the process. We all go through it, and you emerge on the other. It's like the Bene Gesserit test box in Dune, right? You just have to keep your hand in there, and then you emerge on the other side, a changed programmer. You'll never be the same again, and you'll be better. We pass through the borrow checker as it passes through us. All right, with that out of the way, now let's really start using the type system to do some cool stuff. Random user, thank you so much for the follow. So, we're gonna do something else I think that is super cool with Rust. We're going to take advantage of its type system to define our choices. Okay? Now, if I were doing this in Python, I might write like a list of choices, rock, paper, scissors, and do it as strings and make sure that my input were lowercase or whatever. Forget that noise. I can make algebraic types in Rust, right? I can define symbols that are the actual objects that I want to have as my choices. Okay? With an enum, these are not unique to Rust in any way, but the way that Rust implements them is pretty cool. So let's define our enum choice, which is just going to have 3 variants. There are only 3 variants in this version. Rock, paper, scissors. What other languages have I used? Oh boy. My first programming language was Python, then I went to PHP. I've done JavaScript, TypeScript, Elm, Haskell, PowerShell. What else? I think I said Elm. Oh, right. Racket and Scheme. Clojure. C#, although... oh, right, Bash. And, yes, Nim, although we don't talk about that. I collect them. I collect languages. In fact, the other option for tonight's stream was going to be me exploring Elixir live on air, and that may still happen at some later point. But the votes were cast and people wanted a reintro to Rust, and I love talking about Rust. Okay, so we have this enum choice, rock, paper, scissors. What we can do with this is then use that set of rock, paper, scissors choices to produce like an absolute defined type for our player choice and our random, or our computer choice. Surprised the C or C++ wasn't in there. So I've done some C, but I actually, I'll be honest, I was really intimidated by C and C++. I think I was introduced to C++ too young, because I tried and didn't do an AP comp sci course. And I just I didn't do it. And I avoided it for a long time, thinking that I wasn't able to. I've done C since then, but you know what the truth is? I learned Rust to not learn C. If you could make your worst enemy only use a particular language, but you also had to use it, what language did you choose? Ooh. Interesting. Probably Rust, because I feel like I would have the advantage there. But there's one language that I'm always super curious about, and I've never had a reason to really dive into it. And I've never really been able to wrap my head around it, and that's Prolog. I think that the idea of a declarative language is really cool. I've just never had a chance to really dive into it. Bruno, good to see you. Okay, so in choice, rock, paper, scissors, what do we do with this? So let's kind of ask the player for the choice. So let's write some function skeletons, function signatures. Say function player choice. And player choice is not going to take anything in, but it is going to return a choice. See how that works? Now we're using the type system. So let's we could say to do if we wanted to just leave this unimplemented and have the checker ignore it. But let's kind of whiteboard this out. So we know that we need to get the choice from the player. Reading from the terminal is a bit of a pain, but we'll get there. So let's just say that we need to read user input, right? But we'll say let player choice equal match. So good. And then so let's say let input equal, let's say rock, just for now, okay? And say let match input. Now we have some, wait, no. Okay, don't worry about the exclamation point there. Match input. We are going to say if it is rock, it returns rock. It's paper. Scissors. And then here's the error check right here. We'll do a break here, or a catch-all to say any other choices. And in that particular case, we won't just return a type. We will say that's not a choice, and re-invoke player choice. I'm gonna get yelled at for this. Yes, because we need to say player choice. Okay. What have we done here? We've done a lot of really rusty stuff. The first, we are defining a variable called player choice here, which is going to be of type choice. And what are we setting it to? We're setting it to the result of this match statement. And this is about as rusty as it gets. The match statement is ubiquitous in Rust. What we're doing is we're matching a value against an enum variant or different kinds of values. There are lots of ways that we can make this happen. But the different branches, right, need an outcome. And so in the case of rock, we have paper, scissors, and for each one, we're saying, okay, make, if the player input is rock, like so, we're going to assign player choice to this variant of the enum. If it's paper, this one. If it's scissors, this one. And if it's anything else, we are using curly braces to say, don't just return a thing, execute some code, and say that's not a choice, player choice. And then at the very end, this is another important Rust thing. Without semicolons, Rust returns the last statement of a function. So the last line in a function, if it doesn't have semicolons, it will return that value as the return of the function. If I put a semicolon here, by the way, look, it starts screaming at me because now Rust thinks that I'm not returning anything. It says, look, expected enum choice found nothing just because I put that semicolon there. Take that away. Now Rust knows that I'm returning player choice. Match has seeped so deeply into my psyche that I now do match case statements in Python by default. I've got good news for you, bud. Isn't Python 3.12 introducing match statements? Does that mean you could get rid of let player choice and the last player choice remove the semicolon in the match statement? Yes! Thank you for getting there, the tattooed technologist. That was the next thing I was going to say. Oh, Python 3.10 has them. Yes, you're absolutely right, tattooed technologist. We don't need this variable. We can just say match input, remove this semicolon, and remove this. And the function is implemented with one fewer variable. Absolutely correct. Okay. I also heard that Python 3.10 is a switch case statement. Is that correct? Wow, I don't know. I don't know. You wouldn't need both. I think it just has the match. But yeah, no, you are right. Oh, it's the same thing. It's match case. It's called structural pattern matching. It's PEP 0364. Check it out. Oh, this is cool. So it has guard clauses too. But Towards Data Science has a better explanation of the match case. So you've got match and then case, 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 case. That's very cool. I am going to start using that a ton more. Okay, so we got player choice. Now we need computer choice, right? Which also is going to do something, right? And then we have to say returns random. And so now, right now we can just say return rock or choice rock, I should say. By the way, if you don't want to, this is kind of a cool trick. If you don't want to have to do this, you don't have to. Inside your scope, you can say use, which is the import statement. You use choice, rock, paper, scissors, like so. And then you can just refer to them by name. So here we can just say rock. And then it just works. And it's yelling at us because we're not using either of these two other variants. But we can have them. Yeah, isn't that cool? The use statement is, we haven't even gotten to importing modules, but that is how you do it. But you can also use it to change your namespace so that if I just want to name the thing, like I can put this down here to make it even clearer. Yeah, they're scope dependent. These curly braces aren't just instead of indentation, they have a meaning in the code. Especially in Rust, because Rust uses those curlies to determine how long data should live. Anyone have suggestions for learning Rust? You're right here. This is it. Stick around, kid. No, but in all seriousness, random user, if you missed the beginning of the stream, the two things you need to get started are the Rust book, which is this is the book, right? And it is the same book that you buy from No Starch Press, but this is just the ebook version. That's part 1, and then Rust by example. No kidding. The primary sources for Rust are good enough that I'm recommending them as your starting point. Okay. So we've got computer choice, we've got player choice. I wonder if anyone has a CS course based on Rust. Not yet, but stay tuned. Okay. Let's get rid of all this greet. So now let's solve some actual problems. Right, we've kind of... This is not doing anything, but now we have to start like getting the player choice. Oh, and then function play, right? Oh, we also have to determine the victory condition, right? That's the last thing. So I'm going to add a little bit more documentation here. This is super important. With triple comments. What this does is it tells Cargo how to build documentation for my project. So right above your functions, if you have these triple slashes, these are doc strings. Just like you have special doc strings in Python, this is how you do it in Rust. So here we'll do gets player choice, confirms it's legit. Okay. And then in this particular case, trip quotes or trip slashes, and then, and by the way, this is markdown sensitive. So if I put markdown syntax in these comments, it will render correctly. Render, you say, hold on. Hold that thought. Let's do just that much. And we'll run cargo doc -- open. All right, it's opening in Brave. I gotta fix that, but whatever.
All systems are go for entry, descent, landing. We are currently 6 minutes landing at the Gusev crater in the southern hemisphere of Mars.
Hey, look, functions and documentation formatted the way that it would be if you were to publish it. This is how the documentation is published. So you have your documentation built right in line. right? So if we go to computer choice, check this out. I'll go to computer choice. See how it says gets random choice? Hey, look. You see how I did that highlighting thing or that bracket thing? It's linked to the enum. How great is that? So I highly recommend doing doing your doc strings correctly when you're writing functions in Rust. It'll save you a huge headache in the long term. We'll do one here as well. Okay. Oh, right. So how do we determine who won? We have a computer choice, player choice. We have to determine who won. Luckily, we can write with the match statement, it is trivial to write a function to determine outcome. But think about your outcomes. How many outcomes are there? From one perspective, right? So from a player perspective, there are 3 outcomes. Win, loss, or draw. Sounds like another enum. Enum, outcome. Win, loss, draw. Have you noticed that I've written strings in one place? Just when I'm going to have to parse user input. That's it. I'm not passing string data anywhere else. And why is that cool? That is cool because it reduces the possibility space for error. The fewer things I have to, the fewer bits of text that I need to monkey around with, the fewer chances I'm going to make a mistake doing so. These are symbolic types that are just defined as objects in code, right? It's like anti-bash. There's no text parsing once we're past the user layer. And we get away from user input just as quickly as possible by turning it into one of these enum variants. And that's a philosophy, right? It's a way of saying we have the ability to define these types, so let's do so. We should never have a question in our code about what data type something really is. Okay, so now with that in mind, let's write the code to determine the winner. Okay, so we'll say function play, or say compare, maybe. And say player choice. Is going to be a choice, and the computer choice is also going to be a choice. Not particularly interesting. And what are we returning? We're returning an outcome. I was an English major and I was an English teacher, so I'm going to nerd out about this a little bit more than probably most people. But I think this is beautiful. The way that the type system is expressing the idea. Once you understand this, how clear is it what this function does? Just because it's using types. Yes, also, yes, I am a KDE Plasma. I've been a Plasma user for years and years and years. What we really got to do once this is done is write it so the computer always wins. We don't need to give the robots any more help than they already have. So here we will say match player choice. Ponidzin, thank you so much for the follow. So this is going to look a little bit funky, but I think you'll understand the logic behind it here. This is the messiest part of the code, and there's just kind of no way around it, just because of the branching nature of game theory, basically. How many... All right, game theory nerds. Tintin Takaya, thank you so much for the follow. How many possible outcomes are there? Overgrown Carrot, thank you so much for the raid. Welcome raiders. Come on, game theory nerds. How many possible outcomes are there? Nine. What is the project? Yeah. Welcome. So this is an introduction to the Rust programming language, so we're doing something very, very simple. We are writing a rock, paper, scissors game in Rust to get familiar with the language, how it works, how to build a project. So very simple. So far what we have is we have a player choice function. We still have to implement the user input component of it. That's details, right? Returning types is what we care about right now as good Rustaceans. Computer choice, same thing. It's going to return a random one of our choices eventually, but right now it's just returning rock. And then we have to write our comparison, determine who won. But the core of our game are these two enums, these choices. We are not using strings. We are using union types, right? We are using what would be called a union type in Haskell. So, but an enum in Rust, where we have three variants of choice, rock, paper, scissors. There's gonna be a fourth, but hang on. And it isn't shotgun. I'll let you puzzle on what the fourth enum variant for choice might be. But then we have three outcome variants as well, win, loss, and draw. So now we're gonna write the compare logic. So match player choice. Don't forget, we can do our cool trick as well, so that we don't have to do choice : we can refer to them by name by using that import thing again, or that use thing again, right? So we'll say match player choice. So if it's a rock, what do we do? We're going to match computer choice. I know that it's strange that we have a 2-level match here, but this is the nature of the branching logic here. And I don't have to write a single if. I could do this with an if, but I don't have to. Hey, we're hacking live. Good to see you. Okay, so rock. What are the possible options? If the computer chose rock, what's our outcome? Draw. If it chose paper, that's a loss, because we're thinking from the perspective of the player. Hey, Tintin, not right now, because we did that. The video's recorded. It's saved in YouTube. I will do that eventually. And that's a win, right? Rock beats scissors. So rock to rock is a draw, rock to paper is a loss, and rock to scissors is a win. That's our first game tree. If the player chose paper, so it's a little bit of copy pasta here, but understandable copy pasta, right? Oops. So, paper rock, that's a win. Paper to paper is a draw, and paper to scissors is a loss. And then finally, to scissors. Scissors to rock is a loss. Scissors to paper is a win, and scissors to scissors is a draw. And that is our game logic. Because we did a match without a semicolon, this is what will be returned. We're returning an outcome at every possible branch, and so our return type is satisfied. And that's it. We have implemented the logic for comparing the game, determining the winner for each round, at least. Oh, what did I forget to do? I forgot to use outcome, right? Use outcome, win, loss, draw. There we go. That gets rid of that error. And you see how quickly Rust Analyzer picked that up. It's really, really speedy at determining issues. And I think pretty good these days at explaining what the issues are. Okay. So we have the game logic pretty well done. Now we're into the nitty-gritty details, the stuff that that which I do not like to do, which is definitely user input. Okay, so to do this, we have to import some stuff, okay? And let's go to the Rust documentation to take a look at what we have to pull in. Go to standard IO. Yeah. So this is pretty much what we want. The standard IO, standard in. And we have to sort of store it in a place, which is very C-like, right? It's not just the input function in Python. So this use that we saw before is what we're going to use to import this module. And we will put that all the way up at the top. And I only really need the standard in function. And so let's go get that player input. This is going to be a little bit different. So we're going to use a string to store our input. It's nice that we can do that, right? We don't have to do a raw byte array or anything like that. So to do that, we will say let input string, or we don't even have to do that. We can just say string new, which constructs a new empty string. Now, the reason we don't have to manually put the type definition in for that one is because it's obvious. Based on what we're invoking. If the compiler can figure out what your type is going to be, you do not have to manually put it in. And Rust Analyzer, this gray thing right here, is Rust Analyzer giving me hints. There's a bunch of that you've seen. You can turn that off, by the way, if you want to. If you, or no, what is it, Control-Shift-P? Yeah. Rust Analyzer. Disable hints. I'll look for it. But yeah, you can disable the inline hints for Rust Analyzer. But, so we have this input string. Now, we're going to say let equal standard in. Also, again, we don't need the type definition. We say standard in dot read line, right? And read line, we need to give it a reference. If we hover over this, it'll say that we need to give it a reference. Hold on to the mute for a second. To a string. Great. We already did that. We have an input. So we're going to say a reference to a string. So a reference is ampersand, and we say and input. This will not work. And the reason why is because if you looked carefully at the way that was defined, it needed this and mute, meaning a mutable reference. What does that mean? When you declare variables in Rust, by default, they are immutable, meaning that you set the value and you cannot change them. That is the default in Rust. If you want something to be changeable, mutable, you have to explicitly say so, and in this case we have to say so in two places. First, when we define the variable, the string itself has to be mutable, because we're going to be adding stuff to it, with let mute. That's the first thing that we need to do differently. And the reference has to be mutable. So we say and mute input. So that part stops yelling at us. And now we can match input except we're not really done here. And this is why strings are kind of cool. First of all, we need to guarantee that this thing works at all. So let's just print line input to guarantee. Let's say like you chose, like so. Let's just do that much. I'm going to comment out the match here for a moment. And we'll say we'll just return rock again so we can do some testing. Okay? So our main is going to be player choice. Notice that we don't have any showstopper errors. We have some stuff that the compiler will tell us about that we can improve. But for right now, the code should run. And we're going to do one other thing, though, which is ask for user input with a print line. Yeah. We'll make this pretty simple. Okay. Let's run our code. Check it out. So we had a bunch of compiler messages, all warnings, but not errors. And the reason it's doing so is that a bunch of our stuff is never used. And it's like, why do you have this in here? That's fine. But it's still asking us, hey, rock, paper, scissors. So our code is running. So let's choose rock. And it says you chose rock. So our input is working. That's cool. Let's run it again. It's echoing me perfectly. That's a problem because I'm matching on lowercase, right? So we have to do a little bit of cleanup there. That is... There's also one other issue, but I don't know if it's obvious. Does anyone know? If anyone has ever done any string parsing, you may know what the issue is. Anyone want to take a guess? Other than normalizing the case of my choice, what's the other thing that I'm going to have to do to make sure that the match works? Let's go check out strings and see what we can do with them. Strip white space. That's right. There's a line break in there that we don't want. And in fact, you can see it kind of, because we did print line, right? But then there was this empty space before I got my terminal back, and that empty space was the new line that was included after I pressed enter when I typed in rock. That's what that is. That's why I got this space here, because there were in fact 2 new lines. One from print line and one for my input. So we got to deal with that. Let's take a look at what we can do with strings to fix that. In both cases. So all the way down here, oh, too far. We have a strip suffix. Oh, there's trim. Trim is what I want. I always get those confused, but trim is what I want. Returns a string slice with leading and trailing white spaces removed. Fantastic. That gives us a string reference, which is fine. And then it turns out that there is such a thing as a to ASCII lowercase, which gives us back a string, actually. So we can chain some functions here. So what we'll do, right, is we will say, instead of match, that input can be what it is. But instead of trying to deal with it here, let's just deal with it here. Match.input.trim to ASCII lowercase. Does that return a result? No. Oh, but this does. No. What's the problem here? Oh. And since we do need a string reference for that, we'll put an and ampersand. What is your problem? There, quit your whining. As stir turns it back into a string reference, which is what we wanted it to be in the first place. So that's a little bit funky, right? And some of this is where Rust, can get confusing for new programmers, which is we're working against types here. I have to compare string references to string references. That's the deal. If I were doing an equals comparison, like 2 equals 2, that would be fine. But because it's a match statement, the types have to match up. And that's fine. Okay. Now that that's done, we can get rid of this last bit here. Now, let's think about this. Before we go any further, has anyone figured out what that other choice variant has to be? Anybody? Bueller? Game programming is fun, isn't it? Unknown is a super good guess. We've handled unknown already with the that's not a choice, which just kind of recurses it back into getting a player choice. We've handled unknown implicitly here. There's one other option that we super need. There it is. Quit. We use quit as one of the choices to stop the game. That messes with a bunch of our stuff, though, right? Because the truth is... So, actually, I'm rethinking this. In other programming languages, this is the way that I would do it. But I actually think this is the wrong move here. I think we're going to keep this pure because of the way we implemented compare. Never mind. What we will do, though... is have a break function. So in order to do that, we're gonna have to use sys std sys. Come on. See? I don't remember this. I've written this particular bit of code like 100 times and I still can't remember where it lives. SD process. That's what we want. So back to code. Use std process exit. Okay. So we'll have a quick check here. Right? So say now we could do this with a match, but it would be weird. So we won't. In this case, we will use an if statement. So you'll finally see an if statement in Rust. In fact, up here, let's even clean the input because we know we're going to need to do that anyway. So we'll clean the input with this. Because we already made it mutable. Input equals input trim as stir. Then we can say, no, not that, just this. And then we can take that. That much we know. So then we say if input equals quit, print line, thanks for playing, and exit 0. That's a little sloppy, but it'll work for now. And the reason it's sloppy is because usually you do want your exit checks to be in main. I don't like my functions to have side effects like that. But in this case, it would be okay. All right. So our main is player choice. Let player choice equals player choice. Let computer choice. Oh, now we need to do the computer choice thing, which means it's time for some random numbers. My favorite thing in Rust, or for randomness. Unfortunately, Rust doesn't have random built in. It is a crate, so we actually have a dependency. It has the capability of doing pseudo random number generation, but it left that as an exercise for the programmer. 166 million downloads. This is one. Yeah, there are. So there was a reason for that. It sounds insane, but there is a reason for that. The reason for that is that Rust is a systems programming language, meaning that there's no reason for it to have a pseudo random number generator inside of it when it doesn't know how you're going to implement it. By the way, C is the same thing, right? How do you get random numbers? You're actually using like dev random, or you're using an implementation below that. So with Rust, because it's a systems programming language, it is like you can use whatever pseudo random number generator you want, right? That's on you. And think about all the places that Rust would be. You build operating systems with Rust. You can't make that guarantee just with the language, what the PRNG is going to be. So it seems insane, but there's actually a good reason for it. But this is a pretty good one. The RNG and the slice random, these are handy. So we're going to add rand to our cargo.toml. So our first thing. And so for Tintin, now you're going to get to have your question answered about the dependency tree, or the file tree here. We're in the source folder. This is main.rs. This is our primary program source code. Target is where our compiled stuff goes. Gitignore is gitignore. And then cargo.toml is our package dependency file and metadata file. So we're going to add rand to that right now. And then once that's done, once I save this, notice that right away, Rust Analyzer and Cargo Check go to work. I love this implementation in VS Code. It's actually downloading this stuff for me, pre-gaming it, so that it can check my code when I start using it. Which means that I don't have to download it when I start compiling. Okay, so I know that I'm going to need to use rand. And what am I going to use from rand? I think I want the slice random, the way that I'm planning on this. Interesting. I mean, it's not that hard. There's crazy stuff you can do with rand. Certainly more than I'm about to. Random generators. Do I want the RNG? Just checking. No. I feel like this is harder than what I've done in the past. No. It's rand. There we go. Rand thread RNG. Let's ask ChatGPT. Let's see how good it is at this. Just logging in here. Come on. Pretty much right on the money. Thanks, bud. And this is exactly what I found ChatGPT to be super helpful with, right? It's like, how do I do this one thing? Yeah, it's not always right. It's not always right, right? So, like, I put on Mastodon the other day that it gave me gibberish for an Ansible question I had. It told me to go use an Ansible module that does not exist. But this is pretty much right on the money here. So with this, we'll try... Whoa. Sorry, I'm not in my VM, but I need to be. So with this, we'll do... Right, extern create. I have to define my external dependency. And then use rand. What was that? Rand RNG, which is the random number generator. That's what I was thinking of. Rand RNG. ChatGPT seems highly reliant on one's existing knowledge of a toplet to elicit the answer you're looking for. Yeah, I mean, it's super sensitive to garbage in, garbage out, right? I am being very, very careful with how I phrase my prompt to get something, to get it to trigger on the right source data, right? I'm using the term crate so that it's going to find, because the way that ChatGPT works, right, is that it is assembling language as a series of symbols and essentially is like doing statistical analysis to figure out what is the most probable next symbol to put in place after this one. And that is like a bummer how predictable humans are, but like that is what's happening, right? So if I give it enough of a direction to a source material, it will start pulling answers that probably had to do with the same information, probably being the operative word there, right? And so it very much is sensitive to your input. Okay. So for our computer choice, let's say let choices equals Beck, rock, paper, scissors. And the reason I'm doing this is because I need to give it a this is called a slice, or a vec, really. And I need to give it something like this. A vec is, think of it as a mutable array. I need to give it that. And then it's going to say, let choice equals rand thread range choose choices unwrap. We haven't gotten to unwrap, but we'll talk about that in just a second. Let's see how well the ChatGPT code does there. Ooh. No method named choose found for struct thread RNG. Uh-oh. So that's an L for ChatGPT. We got to actually learn how to do this. Random values. RNG sample, I think. Is that right? Or is that's a value? Random, a few common random operations sequences by the iterator random and slice random traits to sample a single. Next with the use RNG gen range. Yeah. Oh, perfect. Slice random choose following the array of sampling a value from a slicer iterator. That's exactly what I want. Slice random. RNG in our example. Here we go. Thread RNG choices.choose. Oh, it was even easier than that. So it's because it's adding that trait to the thing. Okay, so let RNG equals. Any chance you discussed setting up the env at the beginning of the vid? Sure did. Yep. Talk about how to install Rust, the tooling that I use. Whole smash. Okay, so then we'll say choices.choose. And we have to give it the RNG and mute RNG. Yep. And mute RNG. So how did that work? We haven't talked about traits yet. Just thread RNG. Yeah, we need those. Let's go import those instead. Okay, so what's happening is the slice iterator that we just imported is a trait. And traits are attributes that many different structs, we can talk about structs in a minute, can have. So those functions, as long as they're implemented correctly for that trait, for that type, can do those things. And I'm trying to think of a good... The way that I usually explain traits to people familiar with other programming languages. In C#, they would be interfaces. There are guarantees, basically. Traits are ways of saying, now that we've implemented this, you have a guarantee that this method is going to be present, right? They would be type classes in Haskell. And there are a bunch of traits that we've already relied on without knowing so. So, for example, in order to print something with println, the object or the struct that you are printing requires the display trait or the debug trait if you're printing a debug, meaning it isn't pretty, it's just however the data is represented. Hey, Mark in, is that Montreal? Bienvenue. J'adore Montreal. Love that city. Okay. I need some good Montreal bagels. And why is this freaking out? Oh, because I left a semicolon there. And now... Ah. Perfect. Okay. So now we have to talk about this really cool thing that Rust does a lot as a safety, but will drive you crazy if you're not used to it. And these are... they're monads. Haskell does them too. So there are two types in Rust that you will see implemented to make sure that there is something there to work with. Okay? Option is one of them, and result is the other. And let's take a look at option first to explain why, like what this is all about. That's all option is. It seems pretty simplistic, right? But the implications of it are profound. Have you ever written code in Python or JavaScript or any other language to handle the situation where there's no data to process, right? If your whatever function just didn't return anything, or in JavaScript, if it's undefined, right? If you've ever written code to deal with that, then you have encountered the situation that options and results are intended to remove. Options are an enum, just like our choices of rock, paper, scissors are the outcomes. They're a single type to unify, in this case, two potential outcomes. But the cool thing about enums that we haven't seen in our enums is that they can contain values themselves. So notice that in this case, there are two variants of option of type T, which is a generic term for any type. None, which is just like, there's nothing there, move on. Or some, there's something here. What is that something? Well, it's contained within the some variant, and it's whatever type T is, because this is a generic. You can use it for any type. And what's cool about this, then, is we can then write code that matches these two paths, right? If a function returns an option, we can say match on the result of that function. If it's none, deal with it. If it's some, and then we capture that internal value, now we can assign that value to a variable or process it further, whatever we need to do with it. But now, because of the type option, we've just implicitly handled missing data. Result is sort of the same thing. Result is also an enum, see? But notice that result has a type in both cases, right? So result is like, there's data to be had, or there's an error. Not just no data, there's an error, and now you got to deal with it. And in the case of the result, the OK variant has the data that you're looking for. These are the droids you're looking for. But in the case of an error, it contains this error type, whatever the error happens to be. And then you write code to handle that error, whatever the error happens to be. The error type, the reason this is E, it can't just be anything. The error type has to implement the error trait, which is a little bit tricky. But you can produce one with error, like so. And in both cases, in both option and result, both of them have a method called unwrap that says, I don't care, I am certain that there's going to be a value here, give it to me. And so unwrap is not safe. You should not use it unless you absolutely know what you're doing, but you will see it in Rust code pretty frequently. And it is a way of saying, it's basically, I'm too lazy, or I know for sure there's going to be a value there. There's no possible way in which there won't be a value inside my option or result. And so I just need the value. In that case, just don't make me write a match for both branches, just unwrap it and give me the value. That's unwrap, and we have a situation here that we need it, because we have plainly defined our options here. We have no reason to believe that it will not produce a value. Therefore, even though it's returning an option right now, we are going to unwrap it. Unwrap. Let's try that again. And now our issue is expected enum choice, found, and choice. Oh, it's returning the reference, which is a pain. I mean, I guess we can do that, but I would prefer to do a toOwned. That won't work, right? Because it's not implemented. No. Well, welcome to the compiler. Easy enough, actually. So this is returning an option, a reference back to this vec, right? So what we can do is match choices.choose on rep. And we'll say if it's rock, turn rock, paper, and now we're not returning a reference. And scissors, scissors. And that's it. Now we have one error left down at the bottom of our code here, which is the rest of our implementation. Say computer choice equals computer choice, and then match compare. Player choice and computer choice. And in our main, we can say something like use outcome, win, loss, draw. Now I'm putting these in curly braces because it's not a return value. And we can even do something like print line computer chose, so that we know what our opponent did. Now this may fail, which will be interesting in the way that it fails. And then draw. It's a tie. Or it's a draw, I guess. Okay. Oh, I'm missing the exclamation point on these three. I can fix that. Now, we do have one last error, and this is about how I'm trying to send computer choice. Why? Because our computer choice is what kind of a thing? It's a choice. But Rust does not know how to display that. We can solve this problem a couple of ways. The way that I would like to try to fix it is to try to derive the display trait. This is kind of a cool thing that you can do with traits. We haven't done any of these decorators yet, but with traits, if there is a generic implementation for them, it's entirely possible that we can use the derive macro here to derive display. And in order for us to do this, we have to use do I need that? STD format. Thank you. That's what I wanted. Unfortunately, no. But that's okay. We'll do we'll start with debug to show you how we do that, and then we'll clean it up. We'll import both debug and display, and we will derive debug. And that it's fine with. It has no problem with that. So if we want to do a debug display, we have to change up the way that we do this a little bit. Instead of doing an inline, which is new-ish in Rust, we have to do it sort of an older school way with the debug notation and then put what we're printing out afterwards. So it's a little bit more like printf. Okay. That was our problem. Oh. Let mute RNG. Awesome. Okay, so we have a rock, paper, scissors program here. Let's give it a shot. Some stuff to compile this time, but hey, now we're good. So if we do rock, it says computer chose scissors, so I win. It got the logic right. Let's fire that off again. Choose rock, paper, scissors. I'll do scissors. And actually, let me do all caps to make sure that our type checking is working, or our case checking is working. Indeed it is. Computer chose rock. I lost. So everything's going fine. It's annoying to have to run this one at a time, but our code is working. Now, if we wanted to clean up some of these, what are some things that we can do? Let's follow the compiler errors here. We don't need display, but we're about to use it, so... Although, actually, do I need to? Do I need to bother? Because the printout here looks fine. So, in that case, I'm just going to not import not import display. Take that out, and then remove these curly braces, because I don't need... I'm importing only one thing from that module, so I don't need the curlies. And what else is it running? It says unused import thread RNG. Is that true? Oh, it is because I didn't do it I didn't do it right. If I do this, it should stop yelling at me about that. And then the last thing was result that must be used. So we have a read line on line 86 that I did not use. So remember that we said that some things return results. Well, this read line is one of those things. And if there's an unhandled result, Rust is going to be like, what do I do with this code? We don't actually need it. So in this case, we can just unwrap it and toss it. And don't worry, because it'll die at the end of this function anyway. We're putting what we need into our buffer here. So the result of the read line is going to get tossed. We don't need to worry about that. No compiler warnings. And it runs. Now, our very silly project is done-ish. There are things we could do. We could add like a scoreboard. We could add multiple rounds, all of that stuff. Plenty of space to iterate on this, right? But for now, it's working. So how do we ship it? How do we get this ready to go? Well, we've been doing cargo run to test this. But before we go any further, let's actually talk about tests. And this is actually something that will be new for Husky if he's still around. Cargo also has a built-in test feature. And you can write your test modules if you want. But you can also write them inline if you're interested in doing so. So, check this out. Wrong. Paper beats rock. Let's set up some tests and see how this test decorator indicates that it's a test. I can run it in line, or I can have cargo do it. So we're going to write a test here. Let's say let, or let's just say use choice, rock, paper, scissors. Actually, we just need rock and paper for this, right? Yeah. And then we'll say use outcome. We're going to say win. And then we'll say assert equal compare, which is, we want to say paper for the player choice and rock for the computer choice. We want to assert that the result of that is equivalent to a win. I need a semicolon. Oh, I need to derive debug. That's fine. Let's put the derive debug on the outcome. Now what's your problem? Oh, and partial EQ. I don't need commas there, do I? Consider oh, I did the wrong thing, right? I did partial EQ for choice, not for outcome. Partial EQ is basically the way of saying we can use equal signs for comparisons. And now that I've done that, now that I've added that, our test looks good. And so that's kind of like an obvious test. And just do a little bit of copy pasta here. Put another test in here. Let's say paper draws paper. Change this to draw, and we only need paper in this case. Oh, it's going to yell at me about these extra curlies I don't need. Okay. So, a couple of tests. Just to say paper beats rock, that works. We could say paper draw. We could write all 9 possibilities, but... so if I hit run test here, what happens? The terminal does the thing. I don't like that output at all. If I do cargo test... Isn't that kind of cool? I think that's cool. Where I can do these inline or I can write them in a separate module, but as long as my project has something that has test decorations like this, and I can decorate a whole module, then with a derived test, the whole set of functions will do it. Then I can do kind of my unit testing inline here. Nice to have. I honestly don't do a whole lot of unit testing. I should probably do a little bit more, but I do find that a lot of the situations in which I would use unit testing for are handled by the type system of Rust, right? That the very nature of the language sorts me out. Okay, so I have this thing built, I've tested it, I'm ready to ship. How do I do it? I can do this with cargo build, and cargo build by default will create a debug build. Notice it says it's unoptimized, debug info, all of that stuff, right? Now, if I do cargo build -- release, that builds it for a release, and that changes the way that it is built. And notice that it's recompiling a bunch of stuff. This time it says that it's optimized, and by default it has some optimization. What has it built to? Well, let's look at our target and release folder, and you'll see that there's an RPS executable. What is it? It's an ELF. It's a 64-bit executable. With security baked in. Now, how big do you think this is? How big do we think that this executable is? No takers? .9 megs. So not crazy, but also we didn't import much. Rust binaries get chunky. And they get chunky for the same reason that Go binaries do, which is that they're statically linked. So pretty much everything except libc that it needs is baked in. It is not using dynamic linking. It's not looking across your system for shared libraries that it expects to be there. It is just like, nope, I'm packing all of it inside. And that is why they are a little bit larger, but that also means that they're easier to run in different places. As long as they're compiled for the right target, you can have some reasonable assurance that it's going to run because it's coming with everything that it needs. Now, how do we build to other targets? Actually, not that hard. At least, unless we're doing Mac OS, in which case it's a giant pain. But if I wanted to cross-compile for Windows, check it out. Let's take a look at RustUp, which is the tool that we can use to both, it's what we use to install Rust and what we use to update it. But we also have RustUp target list, which lists all the possible compile targets. Look at all these things that you can point this thing to. We can do WebAssembly. We can do Mac OS. We can do iOS. We can do Fuchsia if we want, and we can do Windows. So if we wanted to do that, in order to do that, we first do RustUp target add, and add that as one of our compile targets. And what it's doing is it's downloading the Rust standard library for that target. You also want to make sure that you have, if you're doing this on Linux and you want to compile to Windows, you want to do sudo, if you're on a Debian derivative, sudo apt install mingw -w64, which is the minimum GNU Windows compiler. Right, this is the thing that allows you to target Windows APIs with your compiler. And as you can see, there's a lot that it needs to get. It's going to get 229 megs. Look at all these modules it's installing. Once it does so, though, we will be able to write an exe directly from Linux. The cross-compilation story is about as good as it gets. I've never seen it easier in any language. Take your time. I really don't know why my virtual machine is hanging so hard. It has plenty of resources. Four cores, it's taking up 12 gigs of RAM right now. Yeah, see? I believe it has to do with the XRDP session. Let's say I forgot what package I needed to install to compile for Windows. Is it referenced in docs somewhere? Would I look, or just Google? That's a great question. If you forgot and you tried to do it, it would yell at you and tell you what you needed. You do need to know Rust up to know the target. But if you needed the Ming W64, then yes, it will tell you about that. Okay. Well, that's taking forever. In the meantime, are there any questions about Rust so far? Or anything that I haven't covered yet that you were hoping to see? What's with this green? Trying to think. Let me go back to I had an outline for tonight, so one question I get kind of frequently when we're talking about Rust is it object oriented? Not really, but also not object oriented. Rust has its pedigree from OCaml. So it does have some functional programming language stuff baked in, but it also has a lot of C++ type stuff going on in there as well. Hey, Fox, thank you so much for the sub. And so there are ways to program in Rust that are very functional, and there are ways to program in Rust that are very object-oriented, depending on what you're doing. So, depending on how you like to... I like to do functional as much as possible, but the structs that you build in Rust allow you to organize your data in ways that make sense the same way that you would in object-oriented sort of fashion. So, boy, this thing is just dying installing Ming W64. Luckily, I have the whole rest of my computer that is working just fine. Whoa, Fox, thank you so much for the 5 gift subs. That's incredibly generous of you. Really appreciate that. CD intro to Rust, and let's do a cargo new struct demo. Panda Ford, I appreciate it. All right, let's go to the struct demo, and I will open up code. Those are my favorite tricks. I can just open up VS Code from within Windows Subsystem for Linux and have it just run. And in truth, Windows Subsystem for Linux is my primary dev environment for Rust, because it just is so easy to get going. All right, so let's think about some structs. What are structs? How do we use them? Structs are, you can think of them a little bit like classes, but don't get too far down that comparison rabbit hole. With a struct, we can store data and then implement methods that those structs can use. But be very careful about thinking about things like class inheritance, okay? And be very careful about class inheritance is really where I want you to be aware when we compare structs to objects. So, for example, oh, you know what? Let's do a car simulation. This is always a fun one. So, let's do a struct car, not cat, car. So we're defining what makes a car a car. In our case, we'll say it's a make, which is a string, a model, which is a string, a year, which is going to be a uint. Now, what is a uint? A uint is an unsigned, or no, usize is actually what I want. That's what I'm trying to say. It's an unsigned integer of the default size for your architecture. So 64-bit, 32-bit. We could also say U8 if we wanted to, or U32 or whatever. But usize is kind of nice because it'll work on either architecture, depending on what your target is. Make, model, year, let's say top speed is also going to be a usize in miles per hour. And let's say accelerate, also usize, and decelerate. Yeah. Okay. Nothing too wacky here. Now, these are the things that make a car a car. Okay? How do we build one? How do we instantiate a car? Well, in order to do that, we have to create implementations for the struct. Notice that there are no methods on that, right? It's just the attributes. So how do we create one? Well, we can make one raw if we want to. Say, let kit equals car, and then we can say make Pontiac model, right? Trans Am, a year, I believe, was 1982. Top speed, say to 220. Accelerate, like 25 miles per hour per second. Let's just, I'm fudging that. I have no idea. Decelerate, let's say 30. And it's mad at me because these aren't strings. So I could solve that a couple of ways. I can make them references, but if I want them to own the data, then I can say .toString. So this is the syntax for making an instance of a struct raw. And that's fine, depending on what you need to do. But what if I wanted to write a constructor? Right? So I could do like car : new. I can do that. To implement methods for a struct, we use the impl keyword. So impl car, and then in that block, we write our methods. So in this case, we could say function new. And function new can take a make, right, which is a string, a model, which is a string, or turn it into, make these stirs so it's easy. And then, let's see, year, again, is use size. Numbers, raw numbers, just get moved around. You don't need to worry about ownership with them. Top speed, use size, accelerate, use size. And see how this is getting kind of long? We might, in this particular case, do one of these. Okay. Accelerate and decelerate. And it returns a car. And notice that it has the same feature as JavaScript does now, where I don't have to do make model. It's like, okay, we get it. That's what you want it to be. But in this case, it would be make to string, right? And now I have created a constructor. So if I wanted to do it this way, it would be like this. Comment that out and just say let kit equals car new. And now I say Pontiac, I can just pass that, right? Trans Am. And see how it's figuring it out for me. Year 1982. Use size 220, or top speed. Accelerate 25, decelerate 30. I've made a struct. Now, how do I make it do stuff? I can make it do stuff by adding actual methods to the struct itself. This was onto the instances. So notice that new just took data and returned a new car. But what if I wanted to put a method on the car instances? I can do that. But I need to make the first argument to the function a magic keyword called self. So we'll say hub function so that it's accessible. Actually, didn't need that because it's local. So function, let's say gas. What we're doing is we're trying to simulate acceleration, deceleration. So with gas, what actually we need to do is add something, which is our current speed, which is going to be mute use size. Mute current speed. And do I just not define it as mutable? It'll tell me. I think I define it mutable later. I swear it's over here, but whatever. The whole point is that now the current speed is 0. Okay? So what function gas does is it takes a reference to self, and it doesn't need anything else. we don't know what we want it to return. Maybe, yeah, we do. It's going to return the new speed. So we'll say naively say self dot, oh, and we got to borrow it as mutable, right? And mute self. There we go. Self dot current speed equals, or plus equals, because that's a thing you can do. Plus equals self dot accelerate. So basically we're saying every second in the simulation, and then we're going to return self dot current speed. And now we're returning, so now we have a gas function. Now it's naive. What's the problem with the logic here? What's the problem with the logic here? This will allow a car to accelerate infinitely. So we have to make sure let's say let new speed equals self.current speed plus accelerate. If new speed is less than or equal to self.top speed. Actually, just less than self.top speed. Then self.current speed equals new speed, right? Else self.current speed equals self.top speed. So we're capping it, right? Saying you can only get up to your top speed. You can't exceed it. And similarly, we write a brake method, right? Self.current speed minus self.decelerate. And if the new speed is greater than 0, not self.top speed, we set it there. Otherwise, we set it to 0. It has stopped. We've implemented gas and brake for our car. And so if we wanted to, we could create a race between two different cars and just say, like, for X number of seconds, have them drag race and have them not only accelerate at their acceleration rate, but then also decelerate before they hit like the end of the track, right? If you wanted to see how that works. If you wanted to do something like that. Pretty fun to do simulations like that. And gas and brake, important features in a car. Yeah, they're both automatics, so we're not going to worry about shifting or anything. How's our install doing? Is this finished or is this still freaking out? Oh no, it's done. Good. So coming back to rock, paper, scissors, just to finish this out, because the question was how do we build? So we installed this target, right? So now that we've done that, we can actually say cargo build, release, and if we give it a target option, like so, it will build. And if we look at our target release, nope, just kidding. We look at our target, there's an x86 64 PC Windows GNU, inside of which there's a release and an rps.exe. So we've created an exe with minimal trouble, which will, it's a console application, obviously, but we've compiled it to run from Linux over to Windows. And it's about as good a cross-platform compilation story as I've seen. So that's all it takes. Now, when you are ready to publish your crate, if you are interested in doing so, you can run cargo. Is it push or publish? Cargo publish. Now, in order to do so, it's going to make you add some things to your cargo.toml. It'll yell at you. In fact, if we try it now, we just say cargo publish. It'll say, hey, you're missing stuff. Right? Including a login token. Because we have to log in with our cargo account to make that happen. But also it'll say, hey, you need to add different things. So, for example, if we look at the offensive Notion crate, of which there is one. Yeah, there is. I think. Well, we know that there's a PW fuzz. If we look at the source code for it, take a look at... And take a look at the cargo.toml for this thing, you'll see that it has a name, a version, an edition, a license, an author, description, a repository, and a README. These are what you need to add to a cargo.toml file in order to make it actually run, or actually publishable. So then next steps in Rust. After you've got the basics of the language down and you're familiar with building, basic programs, the next step is really to start learning about building structs and working sort of functionally. And I will say that for me, this isn't going to be true for everybody, but for me, one of the nicest places to work on some of those basic techniques is in Exorcism or Code Wars. So in Code Wars, right, if we go to Rust, we'll try... let's do Rust, and we'll do a very basic exercise just to give you an idea if you're not familiar with these things. This is where I'm going to burn myself by picking something really, really... Squaring an argument. Fine. Right? Now you have to write a function that takes an argument and returns the square of it. This is as simple as it gets, right? So, train this one. But doing these really helps out. Define a function square. Okay. Function square. Takes a signed integer of type 32. And returns the square of that integer. Okay? I times I is obviously the most simple of those implementations. Except... returns the square of that integer. There we go. Cool. And then what you want to do with Code Wars, right, is look at everybody else's implementations. So there's also an n.pow, which now you know exists. So the ways in which people solve these problems will tell you more about the language. That was an obviously, contrived example, but worth your time to practice these. Seeing how other folks elegantly solve these problems really helped me become a better programmer. All right, I think that is going to do it for tonight. We've gotten through the material that I wanted to get through for our intro to Rust. We'll run one of these again eventually, but don't forget that this is recorded. We have it both on Twitch and on YouTube. So for now, we are going to raid one of our friends from the Hack List. If you don't know about the Hack List, they are a group of InfoSec streamers, and we are Legion. And I think Anya is going to be our target tonight. So I'll be back on Saturday doing some some more directly security related stuff. Until then, friends, please be good to yourselves, be good to each other, and happy hacking. I'll see you next time.